So we're talking about pressure, PSIG, PSIA, PSI, period. Okay, so here we have a nice infographic showing the relationship between PSI, pounds per square inch, PSIA, pounds per square inch absolute, and PSIG, pounds per square inch gauge. Cetra provided this for our viewing pleasure. It's a great infographic. I like it. It sort of tells a story, what's going on. The PSI, of course, pounds per square inch, the most basic unit to measure pressure. The majority of pressure transducers, which is something that are all over in HVACR, are specified in pounds per square inch. Okay? This type of pressure measurement is a very appropriate and common issue in HVACR. Just like that, okay? This scale down below here shows you, and we're just talking about air pressure in this case. As you can see, it says air pressure, all right? Right here in the middle of this image is atmospheric pressure. And atmospheric pressure normally, as far as we're experienced in, is measured not by one of these, it's measured by a barometer. But if you took a tire gauge, which this would be a PSIG device, pounds per square inch gauge, you took this gauge and, like I am right here, holding it up in the atmosphere, or I'll take one in each hand and hold it up in the atmosphere. What do they read? What do they read? They read 0. So these gauges are exposed to atmospheric pressure, but they read 0, which means basically these are calibrated to atmospheric pressure. In other words, 0, they aren't going to measure anything unless it is above atmospheric pressure, like the pressure in your tire, for example. The pressure in your tire is probably around 34, 36 PSIG. Now I have something to measure with the gauge. And that's what they're built for. They're built to measure pressures above atmospheric pressure. All right. So, being that said, notice atmospheric pressure also equals 14.7 PSIA. We've already talked about atmospheric pressure, and you recognize that atmosphere has a weight. That column of air, 6,200 miles tall, on 1 square inch of surface is going to weigh 14.7 pounds. Anything below that, we consider a vacuum. Okay? And that's the gist of where we're sort of going with this, is to understand the difference between a positive pressure and a negative pressure. Everything is referenced at atmospheric pressure. So there is 14.7 pounds of pressure on the surface at sea level, on a square inch of surface at sea level, because of that 6,200 mile column of air, 1 inch square. As you go higher up in the atmosphere, of course that pressure goes down because there's less air above it to provide weight. So there's a large portion of a scale, 14.7 pounds, that is below atmospheric pressure. If you're below atmospheric pressure, you're in a vacuum. If you're in a vacuum, it's usually going to be measured by PSIA, or it could be inches of mercury vacuum. We're not going to get too detailed in there at this point. However, why do I bring this up? Remember, this is just sort of an intro to pressure. At some point in time in your career as an HVAC refrigeration tech, you may need to calculate compression ratio. And when you do that, you will use absolute pressures. You will not use gauge pressures, you'll use absolute pressures. Now you get on the positive side of the scale, PSIG, as it shows here, gauge pressure relative to, and it's all relative to atmospheric pressure. Okay? It gives you the example of 100 pounds above atmospheric pressure. So that would measure, on this gauge, 100 PSIG. If you are using an absolute pressure gauge, which there aren't any really, you would be measuring 114.7 psi A, absolute pressure.